All right, welcome back to our discussion about using double and half angle identities. In this video, we're going to actually use some things that we know. We're going to be given a specific angle, and then we're going to need to find the trig functions of twice that angle. So let's jump in and give that a shot. Okay, so here's an example. We are going to use the double and half angle formulas to find the exact values of trig functions. And when it says exact values, that means no decimal approximations, okay? So let's say I'm given a right triangle here. And I'm telling you it's a right triangle even though it's not marked as a right triangle. And I know that I'm given an angle theta, an acute angle theta here, and the opposite side is 3, and the hypotenuse is 5. And I am tasked with finding the values for sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Now we can use decimal approximations and use like our calculator and do an inverse sine to find the measure of theta and then double it and then do all that good stuff. But what we're tasked with here is finding the exact values, which means I'm going to need to use those formulas, okay? So the very first thing I want to do is actually find the 3 primary trig functions for theta. We're going to find sine theta, cosine theta, and tangent of theta. All right. Now sine of theta is easy because we're given the opposite and the hypotenuse. So we can say without a doubt sine of theta is going to equal 3 over 5. Now the next thing I'm going to do is use my Pythagorean theorem and that relationship to find the missing side of this triangle. I can say a squared, or 3 squared, plus b squared is equal to c squared, or 5 squared. All right, which means that b squared would equal 5 squared minus 3 squared, which would mean b squared is equal to 16. And in this case, since we're dealing with just a distance, b would equal 4. Okay, so if b is 4, that means now I can identify the cosine of theta, and the cosine of theta would be, what, 4 over 5? And the tangent of theta would be, what? Yeah, you're right, 3 over 4. Okay, great. Now that I have these things, I can use identities, those formulas, and find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So let's go to those formulas. We know that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. Okay. Well, let's sub those things in. I know what the sine of theta is. Sine of theta is 3/5, so I can sub in a 3/5 here. And I know what the cosine of theta is. That's going to be 4/5, so I'm going to sub that in here. That replaces the whole expression, cosine of theta. And 3/5 replaces the whole expression, sine of theta. Okay, so let's go ahead and do that. So what we have here is 2 times 3 over 5 times 4 over 5. So now I'm just going to multiply numerator times numerator times numerator and place that over denominator, which here is 1, times denominator times denominator. So we should end up with the sine of 2 theta equaling 2 times 3 times 4 is 24, and 1 times 5 times 5 is 25. 24 over 25. That wasn't too bad. Let's try cosine of 2 theta. All right, cosine of 2 theta. Now remember that there were 3 different formulas. And almost exclusively, you're going to choose to use the cosine squared of theta minus the sine squared of theta formula. And the reason why is it produces for you a common denominator every single time. Remember that cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse, so the denominators here will be our hypotenuse squared. Okay, that is lovely for us because then we don't have to come up with a common denominator on our own. So again, we're going to replace cosine squared theta with cosine theta, 4 over 5, and square that. And we're going to subtract sine of theta, 3/5, and square that. Okay, so it's going to look like this. Our cosine theta is 4/5, and it needs to be squared, minus our sine theta is 3/5, and we're going to square that. So when I square those things, I would end up with 16 over 25 minus 9 over 25. And with the common denominators, it's a piece of cake. We just take 16 minus 9 and place that over 25. That gives us 7 over 25. All right, so now we've got sine of 2 theta, and I've also got cosine of 2 theta. So now I want to use tangent of 2 theta. Tangent is always a little bit messier, but it's not too terrible. Okay, so let's look at that formula. Tangent of 2 theta is going to equal 2 times the tangent of theta divided by 1 minus the tangent squared of theta. And so I'm going to use this 3/4 and I'm going to sub it in where I see tangent of theta. And I'm going to put it here, tangent of theta, and then square it. So let's go ahead and sub those in. Okay, there's a lot in here. Just focus on the first thing. 2 times 3/4, that's 2 times the tangent of theta. And then 1 minus 3/4 squared. Okay, so let's go ahead and simplify this. The first simplification is 2 times 3/4. That's 6 over 4, which is just the same as 3 over 2. Now here, we're just going to multiply the 3/4 times the 3/4 and get 9/16. Now we are going to want to subtract it from 1, so we need a common denominator here. We're going to make that 16 over 16 minus 9 over 16. So we'll end up with 3 over 2 divided by 16 over 16 minus 9 over 16. Can you guess what the next thing is going to be? It's going to be cleaning up this denominator. So what would that denominator end up looking like once you clean that up? Should end up with 7 over 16. So 3/2 divided by 7 over 16. That's the same as 3/2 times 16 over 7. All right, and now you can just multiply this numerator times numerator, denominator times denominator, gives us 48 over 14, which then would simplify to 24 over 7. Fabulous. Okay, now another kind of shortcut. If you have to find all three, then you don't actually have to go through this process for tangent, because remember that tangent is equal to sine over cosine. So if I know that 24 over 25 is the sine of 2 theta, and if I know that 7 over 25 is the cosine of 2 theta, I can say without a doubt that the tangent of 2 theta would be 24 over 25 divided by 7 over 25, and then just simplify that. They both have a denominator of 25, which means I can multiply the whole things by 25 and just get 24 over 7, which is a lot simpler than this process. Now, if you're tasked with just finding the tangent of 2 theta, you're probably going to want to go ahead and use this formula. But if not, then go ahead and use the sine of 2 theta divided by the cosine of 2 theta and just justify your answer that way. Okay.